So we need to find the angular momentum and the torque needed to stop it in 6 seconds. So we have the mass equaling 2.8 kilograms, and we have the radius equaling 28 centimeters. We can say this is going to be 0.28 meters, and we have an angular velocity of 1,300 revolutions per minute. So we can say that the moment of inertia is going to be the the angular momentum will equal the moment of inertia of a disk times the omega, or the angular velocity. This will equal 1/2 mr squared times omega. And this is equaling 1/2 times 2.8 times 0.28 squared, and then times 1,300 RPM times 2 pi radians per every 1 revolution, and then times 1 minute for every 60 seconds. And we're getting that L is going to be equal, the angular momentum is going to be equal to 14.9 kilogram meters squared per second. My apologies. And at this point, we can say, okay, this will be for part A. And then for part B, however, we need the torque needed to bring it to rest. So delta T is equaling 6.0 seconds. We know that the torque needed, the change in torque needed, is going to be equal to the change in angular momentum divided by the change in time. We know that the final angular momentum is going to be 0 because we're trying to bring it to a rest. So this will be negative 14.94 divided by 6, and we're getting a torque of negative 2.49 Newton meters. The torque being negative just means that it's in the direction that is opposite of motion. So opposite of motion. That is the end of the solution. Thank you for watching.